So in this video, I'm going to show you 10 different uses for 3D printer in a manufacturing shop or a wood shop. And I've been really happy with my 3D printer, and I think a lot of people could be using that in their shops, and the software is really easy to use. So I'm going to try and show you that too, but for now, we'll just go through the 10. So first up, you can 3D print glue joints or glue forms for your products. And so if you come take a closer look here, these are some forms that I print up. I print them in 2 different sizes, and this is just for the products I make. I make these hexagon cylinders, and these forms are printed the perfect size so that when we glue them up, we can just clamp them around these little forms and with a bunch of rubber bands, and it keeps them all super consistent. So that's really helpful. It just works every single time. It makes the process super reliable. So that's one thing you can do, is you can print all kinds of glue forms. You know, I designed these myself. I printed them. It took about 20 cents of plastic. So that's use number 1. Use number 2 is you can make any kind of part you need. In my situation, I make these mechanical parts out of plastic that you can't ordinarily make out of wood, because just the parts are too small. It's too weird of a part to really manufacture efficiently. So just really weird parts that are going to break if you make them out of wood, but you can 3D print them out of plastic, and you know, it takes just as long as it takes you to design the part. And then all you have to do is just send the file over to the printer, and you've got an instant part without any kind of manufacturing, any kind of setup. Use number 3 is you can make a jig to hold your work. So in this case, I made this tray, and it's to hold our round boxes, because I'm making round boxes right now, and this is the perfect diameter to fit this part. And eventually I'll have like the whole box just sitting right here, and I can drill straight down. And this thing took more like 3.5 hours to print or something like that, but you know, it's a one-time thing, and it's going to help you with every single product you make. It's going to save you so much time printing something on the printer rather than making this part out of wood. Use number 4 is, if you notice, I recently started adding these cable organizers. So I designed this part myself, and it just keeps the cables from draping and getting caught with your hands or with different things you're using. It keeps everything organized. I got all the drooping cables from hanging off of the lights. I've still got more to do, but you can see that all looks much more organized, and you don't have the cables hanging all over the place. Using it there, we can keep cords off the floor. Really makes things a lot more simpler. And you want to work in a simple environment, because there's enough problems to solve without having to untangle all your cords. So number 5 is 3D printing something that will keep all your tools stick out the same. And the reason you want your stick out the same is because this dust shoe doesn't like to be flexed. So if you have a really long tool sticking out of the machine, all dust is just going to spit out underneath this brush, and you don't want that. You want the tool, you want the brush right up against the material so that none of the dust can escape. It goes right up through here and right through this hose to the vacuum. So you want all your stick out the same. So I just 3D printed this little thing. I designed it myself, 3D printed it in about 20 minutes. And all it does is, when I go here to set a tool, I just put my tool holder right there. I start to tighten this up slightly. I push until we're exactly sticking up 1 inch from the face of the collet, and then I tighten it right down with the wrench. And every single tool here is sticking out the exact same length, and that just helps keep all the dust from getting all over the shop here. Use number 6 is fixtures. So as you can see on this fixture, this is a 4th axis on the machine, and I have a number of different 3D printed parts here. I have this clamp, which clamps parts to the face of this. I have these really weird parts that clamp. So basically these will just screw down and clamp these curved panels to the 4th axis so that we can carve over top. You can see this is 3D printed. This shim that goes underneath the part. Then these hold downs are 3D printed. So lots of different, it would be crazy to try and think that you could make this yourself out of just wood or just out of acrylic, because it's such a crazy part to make. You know, even these little things have some crazy geometry on them, and it's really handy to be able to 3D print those. Number 7, just some more different kinds of hold downs for the CNC. You know, it took me about like 10 minutes, you know, maybe 5 minutes to design these little things, but then the printer can print 32 of these, I think I have, in about 3 or 4 hours. So your time making these little fixture clamps is incredibly small per fixture clamp, because you're making so many of them, and because the 3D printer can make as many as it wants and it doesn't ever complain. So fixture clamps, I have this, I call it the spider. This is another locating part and clamp where I put a part on here. This is glued down to the table, and it just locates it perfectly so that the machine knows where it is, and then I clamp it down with this. You can use the 3D printer to repair things. So when I was milling over here, I switched back and forth between using G54, G55, G56, G57. So the machine had the wrong tool offset at one point, and it plunged into my table and it started to ruin this pallet. So instead of making an entire new acrylic pallet, I just replaced this small little piece. I just measured it up with a pair of calipers. I went to the software, I created a part, I printed it in about 20 minutes. I had this replaced. It's super quick to do small fixes like that, which is nice. All right, that's number 7. For number 8, you notice this new tool changer that I put in myself. So what this does is it keeps all the tools out of the way so that the machine can work up top here and not run into the tools. And then as soon as it needs a tool change, it comes all the way over here. It triggers a solenoid and it lifts this up. And you obviously want this to come to the same height every single time so that the machine picks up the tool and puts it back at the same height. Otherwise, it's not going to go down deep enough, and it's going to try and grab it, and it's not going to grab anything. So you need all these pull studs at the exact same height. So I 3D printed these, I just call them cawls, but I guess they're kind of like stops for these rails. Use number 9 is I had a problem where the machine was dropping the tool. So we'd be cutting and all of a sudden this tool, which is spinning at like 22,000 RPMs or 18,000 RPMs, all of a sudden just falls out of the collet and like falls on the table and rolls off somewhere. It's really bad. You don't want that. So I wasn't sure if it was in the program, a glitch in the program, or if it was this hose, because before it was like this. And if this hose got flexed in the wrong direction, it would hit this button here. You can hear that. So like, you know, you can imagine that hitting that little green button, and then all of a sudden the tool drops out. And that's no good. It scraps your board, it scraps a whole bunch of parts, scraps hours worth of time. So I just 3D printed this little ring, this little orange ring that I designed in about 2 minutes. And it just slips on over the top of this button. And now, no matter how hard you try, the hose cannot get in there to press the button, but a finger can still do it because it's got a point, and this hose is just can't get in there. So that's another nice thing. That's number 9. Number 10, you can just use it for quick positioning to just help you with different things in the shop. I'm thinking more like fixturing. Some people make custom fixtures just to hold parts for assembly, but it's the same thing as I did right here, where I use a webcam to monitor the machine when I'm not in the garage. So if I've got like a 5-hour run or something, I can just set this webcam right here and it'll watch the machine. And the nice thing about it is with this little base that I 3D printed, it's hard to like knock it off or to have it just fall off with vibration. So that's really nice, and I kind of like it, and it just makes everything dialed in. Okay, number 11, we've got a bonus one. Is you can go on Thingiverse and you can find all kinds of free files. So this is going to be for my nephew for his birthday, and it's just a 3D printed shark, which took about 6 hours. It's really cool. Whoever designed this made it well so that all the joints work and the mouth even opens and closes. And so this isn't really a shop hack, but if you get a 3D printer and you start 3D printing toys for your nephews and things, you know, it's going to free up your shop to do other things. So there you go. So there's the use for a 3D printer in a shop. Okay, so now I'm just going to go quickly over the software and how easy it is to use the 3D printer. And especially if you know a 3D modeling program like Fusion or maybe SolidCAD, SolidWorks, it's really easy to just get Prusa's free slicer, and I'm just going to show you guys real quick how easy that is. So I'm gonna design a square, just a cube, a one inch cube, and I'm gonna print it on the printer. And I have not designed any of it yet. I'm just going to show you how quick it is to design it in Fusion, load it in the slicer, put it on an SD card, and put it in the machine. And hopefully that'll just show you how unintimidating it is to use the software. So I'm just going to start timing it right now. Okay, I'm going to go line here, rectangle. I'm gonna go 1, tab 1, enter, extrude. We're gonna go 1. Okay, now that body's all done. I'm gonna do save as mesh, and I'm gonna do STL, because you want to save everything as a STL. We'll call it cube 1. I'll click save. Now I'll go into, this is Prusa slicer, and I'll just do add new, and I'll do cube 1, open. Should I convert to metric because I saved it in inches? Yes. So then it just loads it on here. It already selected a good face, and now I just do slice now. And this is with 0.15 millimeter quality, which is kind of middle of the road stuff, which I usually do. Okay, it's gonna take 51 minutes. Now I'll just hit export G-code, and I'll select the Prusa card. Okay, this is the worst part of it, because, okay, there it goes. So now that card's all, that whole STL file is loaded onto here. The G-code's loaded. I just put this in the machine. It sorts the files, and I click cube 1, and now it's going to heat. It's heating up the bed, and it's heating up the extruder. So as soon as it's done heating, in about 5 minutes, it's going to start printing. Then it's going to take 51 minutes to print a 1 by 1 inch cube. So that all took, let's stop the clock here, 2 minutes, but I mean, I could have done it a little faster if I wasn't explaining stuff and if I didn't have that one glitch with the SD card. But like, that's super quick to make whatever you want to make. It's so fast compared to like turning on a table saw or turning on the CNC mill or putting a part down on, you know, clamping a part down and then machining a 1-inch cube. So it's just such a great tool for manufacturers, and it's so great to make prototype parts on here because you can see it on the screen, but you don't know what it's like going to look like in real life. So you print it on here, and then you have a physical copy that you can tinker with and see what the tolerances are and how easy it's going to break. So I've really been loving using it and having it, and I recommend for all the small shops who are into research and design, who are making new prototype parts, definitely consider getting a 3D printer. And even if you just want to just make little things to organize your shop and to make, you know, the shop life a little better, it's good for that too. So that wraps it up for this video. Thanks for watching. Hope you enjoyed. Let me know what you want to see next, and I'll catch you later. Goodbye.